For 60 years, we had one rule about how the universe works. Galaxies come first. Then, inside them, black holes grow. In 2026, the James Webb Space Telescope found an object that breaks that rule completely. A black hole so massive, so early, that the galaxy around it barely exists at all. Not a black hole living inside a galaxy. A black hole, that is the galaxy. Stay with me, because what Webb found next is even stranger. Here is what every astronomy textbook told us until very recently. A galaxy forms. Gas collapses, stars ignite, structure emerges, and somewhere in the chaos at the center, a black hole grows. Slowly, patiently, fed by what falls in. The black hole is a passenger. The galaxy is the vehicle. Our own Milky Way makes this crystal clear. Sagittarius A star, our central black hole, weighs about 4.3 million times the mass of the Sun. Sounds enormous, but the Milky Way itself contains 50 to 60 billion solar masses of stars alone. The black hole is a rounding error. It is 0.07% of the galaxy's stellar mass. That ratio, black hole as a tiny fraction, galaxy as the overwhelming structure, held up everywhere we looked. Andromeda, Centaurus A, galaxy after galaxy. It seemed like a law of nature, and then we built a telescope that could see further back in time than anything ever built before. The James Webb Space Telescope sees in infrared light. That matters because the universe is expanding. And as it expands, light from the distant past stretches out, shifted toward red wavelengths, and then into infrared. Hubble was mostly blind to it. Webb was built for exactly this. And almost immediately, Webb found something that did not fit. A quasar, a feeding black hole blazing with energy, detected in data that Hubble had collected but could not fully interpret, now confirmed by Webb, Ulysses J142.0928. It exists just 690 million years after the Big Bang. Its black hole already weighs 780 million solar masses, 780 million solar masses, in less than 700 million years of cosmic time. How do you build that so fast? The problem is brutal if you do the math. The standard model of black hole formation starts with a massive star, maybe 10 to 100 solar masses, that collapses at the end of its life, leaving behind a light seed. A small black hole, then it eats, slowly, constrained by the Eddington limit, the point where radiation pressure pushes back against infalling matter and puts a natural cap on growth rate. Even growing at the theoretical maximum, a light seed black hole cannot reach hundreds of millions of solar masses in 700 million years. Not even close. So astronomers proposed an alternative: heavy seeds, a direct collapse of a massive primordial gas cloud, bypassing the stellar phase entirely, seeding a black hole of 10,000 to a million solar masses from the start, a shortcut built into the early universe. But until 2026, no one had caught one in the act. Able 2744, a massive galaxy cluster located billions of light years away, and a natural magnifying glass. Its gravity bends and amplifies the light of objects behind it, acting like a cosmic telescope. Webb was pointed at it, and in the background, amplified and stretched by that gravitational lens, researchers found something extraordinary. Its light is reaching us from approximately 700 million years after the Big Bang. Redshift Z equals roughly 7. We are looking at an object that existed when the universe was less than 5% of its current age. The spectral signature is striking. The gas surrounding this object has a metallicity, a concentration of heavy elements, of less than 0.5% of what we see in our own sun. This is a chemically primitive environment, one of the earliest, most unprocessed corners of the cosmos. And at the center of it, a black hole of approximately 50 million solar masses. Here is where the textbook tears. That black hole represents at least 2/3 of the total mass of the entire system. The galaxy around it, the stars, the gas, the structure, barely exists. It is a thin suggestion around an enormous gravitational engine. This is the inverse of everything we knew. Roberto Maiolino, part of the team that published this result in the journal Nature in 2026, put it directly: this is a paradigm shift, a total revisiting of the classical scenarios of how black holes form and grow. Not a footnote, not a refinement, a paradigm shift. The black hole did not grow inside the galaxy. The galaxy had barely started to grow at all, which raises the question that will pull us through the rest of this video. If the black hole came first, what built it? And could it be that black holes like this one did not just live inside the early universe, but actively created the galaxies we see today? Because there is another class of object that Webb found. And until this year, no one could explain what they were. Starting in 2022, Webb began cataloging something that had never been seen before. Objects that astronomers quickly named the little red dots. Compact, bright, intensely red. Numbering in the hundreds across Webb's survey fields, existing in the window from roughly 600 million to 1.6 billion years after the Big Bang. The debate was immediate and fierce. Were these densely packed galaxies, star formation running so hot that the red color came from their own light? Or were they actively feeding black holes? Their black body radiation shifted red by expansion and dust. The spectra were ambiguous. The light curves were confusing. Even Webb struggled to decide. But a model began to emerge, one that fitted the data better than anything else. The little red dots are feeding black holes, but they are wrapped in a dense cocoon of gas. That cocoon absorbs the high-energy X-rays that a feeding black hole normally broadcasts into space. Strip away the X-rays and these objects look faint, red, and compact. Exactly what Webb was seeing. X-ray quiet, infrared bright, hidden behind their own wrapping. The model had a name, black hole stars, and one of them had just been caught in extraordinary detail. Glimpse 17775, located at redshift 3.5, meaning we are seeing it as it existed approximately 1.8 billion years after the Big Bang. Another gravitational lens amplified its light, this time giving Webb the equivalent of roughly 80 hours of observation, compressed from about 30 hours of real telescope time. What the team found inside that data was extraordinary. 40+ spectral lines detected, including a cluster of 16 iron emission lines so densely packed that the team described it as an iron forest, the signature of gas that has been superheated, processed, and turbulently mixed around a feeding black hole. And that black hole, approximately 5 million solar masses, is not eating slowly. It is feeding at 1.86 times its Eddington limit. Super Eddington accretion. The material is pouring in faster than theory once said was sustainable. The gas is so thick and the accretion so rapid that the outward radiation pressure cannot win. More falls in than escapes. And the cocoon? It does exactly what the model predicted. It captures the X-rays, contains the chaos, and lets only infrared light escape. The wavelength Webb was designed to read. Published in the Astrophysical Journal in 2026 by Kokorev and colleagues, the finding confirmed the cocoon model with a precision that surprised even the authors. The lead researcher wrote, "Everything fits, nothing is broken, and I think that makes the puzzle that is our universe even better." A single object, witnessed as it existed nearly 12 billion years ago, and it matches, line by line and photon by photon, what the theory said should be there. The black hole star was real. So what built these things in the first place? Two candidates remain on the table. The first path, a massive primordial star forms, collapses, leaves a black hole. Too slow. The math does not reach the masses we observe in time. The second path, a cloud of gas in the early universe collapses directly. No stellar phase, no ignition, just gravity, and a black hole, perhaps 10,000 to a million solar masses, appearing almost instantaneously on cosmic timescales. The heavy seed. Some researchers have gone further, suggesting, as a hypothesis, that some of these black holes may have formed in the first seconds after the Big Bang itself, before a single star existed, seeded directly by the density fluctuations of the primordial universe. Supposition. This is a working hypothesis raised in the literature, not an observational measurement. And here is the implication that changes everything. If the black holes came first, if they were already there when the universe was young and dark and unstructured, then they may have done something we never gave them credit for. The gravity of those early black holes could have been the anchor that halted the expansion of surrounding gas. the seed around which matter collapsed, the gravitational knot that organized the chaos into structure. The black hole did not form inside the galaxy. The galaxy formed around the black hole. Speculation, based on an interpretation of Yutzbalis et al. 2026 in current theoretical modeling. We started this video with a single rule that cosmologists had trusted for decades. Galaxies come first, black holes follow. Two objects, found by a gold-plated mirror floating 1 million miles from Earth, reading light that has been traveling for billions of years, have cracked that rule open. What we are left with is not an answer. It is a better question. If black holes could exist before their galaxies, if they were there in the dark, before the first star ever burned, then everything we thought we understood about how the universe organized itself needs to be revisited. Every galaxy we see, including our own, may owe its existence not to the stars that shine inside it, but to the invisible engine that was waiting there first. Webb is still watching, and we are only at the beginning of what it is going to show us. If questions like this one keep you up at night, you are in the right place. Subscribe to the Orbital Signal. We cover the discoveries that rewrite the textbooks every week.